Hello, am I audible and is my screen visible? Can anyone please let me know if I'm audible and if my screen is visible? Okay. So, good evening everyone. Welcome to this NPTEL live session. This is my 8th live session for the NPTEL course Introduction to Machine Learning. My name is Ayan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So in this live session we will discuss some practice problems on week 8 topics. So in week 8 lectures, gradient boosting, random forest, naive Bayes and Bayesian networks, these were the topics that were covered in week 8. So we will solve some practice problems on these topics, and if you have any questions or doubts regarding any of these topics covered in week 8, please feel free to ask your questions. So we can start solving the practice problems. So this is the first question. A man is known to speak the truth 2 out of 3 times. He throws a die and reports that the number obtained is 4. Find the probability that the number obtained is actually 4. So the person reports that the number obtained is 4, and the person doesn't speak truth all the time, so he speaks the truth 2 out of 3 times. So that's why even if he reports 4, it might not be actually 4. So you have to find out what is the probability of the number being actually 4. 4 options are there. You can write your answers in the chat. Pratik Tiwari says B. This is 3 by 4. Okay. Anyone else? For this question, first you have to consider two random variables in order to make this calculation easier. So let's consider two random variables. One is A, which is basically that is the actual number that comes out of the die, and consider another variable which is R, which R is the value that the person reports. So A is the actual value that comes out of the die, and R is what the person reports. R is the number that the person reports. So those two might not be same because the person doesn't speak truth all the time. Pratik Tiwari says D. Okay, so let's see what would be the answer. So the question asks, what is the probability that the number obtained is 4? So that means in terms of these two random variables, the probability that is asked in this question is probability of A equals 4 given R equals 4. So R equals 4, that means the person reports that the number is 4, and A equals 4 means actually 4. So this probability A equals 4 given R equals 4 basically means it is the probability that it is the probability that the actual number is 4 given that the person has reported 4. So this is the actual probability value that you have to calculate. So we will apply Bayes theorem on this thing. So probability of R given 4, R equals 4 given A equals 4 into probability of A equals 4 divided by probability of R equals 4 given A equals 4 into probability of R equals 4 given A equals 4 complement we have to take. So anything other than 4 this should be into probability of A equals 4 plus probability of R equals 4 given A equals complement of 4 into probability of A equals complement of 4. So this is using the Bayes theorem. Now you have to find out each of these terms that appear in this expression individually. So first this term, probability of R equals 4 given A equals 4, that means actual number that comes in the die is 4 and the person is also reporting 4, that means the person is speaking the truth, and the probability of speaking the truth is 2 by 3 from this. So this probability is 2 by 3. So this probability is simply what is the probability of the person speaking the truth, and then this probability of A equals 4. So this is simple. What is the probability of getting 4 in a die? So it's 1 by 6. And now we have to find out these two terms, because this is same as this one and this is same as this one. So we don't have to calculate these two, but we have to calculate probability of R equals 4 given A equals complement of 4. So that means the person is not speaking the truth, he is lying. The number that comes in the die is not 4 but he is reporting 4. So that means this probability is simply the probability of lying for that person, which is 1/3. 2/3 is the probability of speaking the truth, so 1/3 is the probability that he is lying. And finally this probability of A equals complement of 4. So this is basically what is the probability of getting anything other than 4 in a die. So 1/6 the probability of getting 4, and 5/6 would be the probability of getting anything other than 4. So now we have all the individual expressions in this Bayes theorem. We just have to calculate this thing. So 2/3 into 1/6 divided by 2/3 into 1/6 plus 1/3 into 5/6. So this is the thing that you have to calculate, and if you calculate this, it would be 2/7. Option D, 2/7. So Pratik Tiwari has written the correct answer in the chat, which is option D. So this is how you have to calculate this using Bayes theorem. First you have to consider two random variables denoting two things. First one is A, which is the actual number that comes in the die, and R, which is the number that the person reports. And now using these two random variables, we can find out this probability, that what is the probability of getting the what is the probability that the number is actually 4 given the person has reported 4. So 2/7 is the correct answer. The detailed solution is also given here using two different variables, but essentially the same thing. So is there any doubt in this question? Okay, if there are no doubts, then we can move on to question 2. So this is on Bayesian network. Consider the following graphical model. Mark which of the following pair of random variables are independent given no evidence. So no evidence is given, so based on that, which of these pairs are independent? Option A is node A and B, option B is node C and D, option C is node E and D, and option D is node C and D. So which of the following pair of random variables are independent of each other given no evidence? Shankar Lal is saying node A and B. The multiple options may be correct, so you should check all the options. Aditya Chauhan has written option C. Pratik Tiwari has written option A and C. So I've got 3 different answers in the chat. Option A, C. Yeah, these are the 2 answers that I'm getting from the chat. Anyone else? Yeah, so the correct answer is only option A, which is these 2 nodes A and B. So these 2 nodes are independent of each other given no evidence. Other options are not correct. They are conditionally dependent on each other. In this is not conditionally, but dependent on each other, we can say. So A and B are obvious, very obvious that there are no common incoming edges or common ancestors of A and B, so they are not conditionally independent. So option A and B are certainly independent. Second option is C and D. C and D, so these are directly connected, C and D. So there is a direct edge from, oh sorry, not, yeah, C and D, these two. So there is a common ancestor of it. So these two are certainly connected. So this path, this undirected path from C to D or D to C via B is not blocked anywhere. So they are not independent of each other. And then third option is E and D. E and D are also not independent of each other, because this undirected path from E and D via B and C, so the path is ECBD. So this undirected path is also not blocked anywhere because no evidence is given. If C or B, these two, any of these two nodes were given, in that case this path might be blocked, but no evidences are given. So node E and node D, this undirected path from node E and D are not given, are not, this undirected path is not blocked. So these two nodes are not dependent on each other. And the fourth option is C and D. So C and D, there is a direct edge from C to E, so these two cannot be independent at all. So that's why only one option is correct, option A and B. Is there any questions or doubts in this problem? So now question 3, this is again on probability. Two cards are drawn at random from a deck of 52 cards without replacement. What is the probability of drawing a 2 and an ace in that order? So first a 2, then and ace, without replacement. So what is the probability of drawing these two cards in this specific order? Has anyone calculated the answer? I have got no answer in the chat yet. So this problem is not very difficult. Pratik Tiwari has written option D. Okay. So for this problem, you have to pick two cards, a 2 and an S without replacement. So first you have to find out the probability of picking a 2 from 52 cards. So that probability is there are 4 2s in a deck of 52 cards. So that probability is 4 by 52. And once you have picked this 2, now there are 51 cards in that deck, and it is without replacement. So there are 51 cards, and from that 51 cards you have to draw an S. So there are 4 S's again. So probability of picking this one S from the deck of 51 cards is 4 by 51. So this is the probability. First, the probability of drawing a 2 from 52 cards, and then drawing an S from a deck of 51 cards, because it is without replacement. So in the second draw you have to reduce this denominator to 51, because there are no more 52 cards in that deck, there are 51 cards in that deck now. So if you compute this probability, I think this should be 4 by 663, option D. So Pratik Tiwari has written the correct answer in the chat. It is 4 by 663, option D. Does anyone have any questions or doubts? Now question 4. So this is again on probabilities and Bayes theorem. A drug test denoted by this random variable T has 1% false positive. That is 1% of those not taking drugs show positive in the test, and 5% false negatives, that is 5% of those taking drugs test negative. Suppose that 2% of those tests are taking drugs, 2% of those tested are taking drugs. Determine the probability that someone who tests positive is actually taking drugs. So there are two random variables that are already defined here. Random variable T, which denotes the result of the drug test, whether it's positive or negative, and another random variable is this D, which denotes whether the person is taking drugs or not. So using these two variables, you have to find out the probability that someone who tests positive is actually taking drugs. So if you write this probability in terms of these two random variables T and D, so it would be probability that someone who tests positive is actually taking drugs. So probability of D given T, this is the probability that you have to find out. So T is that T means the tests the result of the test is positive, and D means that person is taking drugs. So that's why you have to find out this probability value from all the informations given, like this 1% false positive and 5% false negatives, and also this 2% of those tested are taking drugs. So based on these three different probability values given in this question, you have to find out the probability of D given T. Okay, Pratik Tiwari has already written the answer. Oh no, this is for the previous question. Has anyone calculated this answer? This question might be a little difficult, but you have to find out these probability values that are given in this question: 1%, 5%, and 2%. These false positives, false negatives, and this 2% of those tested are taking drugs. You have to represent these three probability values in terms of these two random variables T and D. Then the question would become very simple. Then you can simply apply the Bayes theorem on this probability of D given T and find out the answer. So in this question, first you have to represent this 1% probability. What is this 1% false positives in terms of T and D? So this is 1% of those not taking drugs so positive in the test. So this is basically probability of the test result to be positive given not taking drugs. So D probability of T given complement of D. So this is 1%, which is 1 by 100. Now this 5% false negatives. So that means 5% of those taking drugs test negative. So that means probability of test result to be negative. So complement of T given the person is taking drugs. So probability of complement of T given D. And now finally this 2% of those tested are taking drugs. So this is simple. This is just probability of taking drugs. So 2% of the people are taking drugs. So this is just the probability. So this was 5 by 100, and probability of D is 2 by 100. Yeah. So these are the three probabilities that are given, and using these three we can find out this probability of D given T. So we will use Bayes theorem on this. So it will be probability of T given D into probability of D divided by probability of T given D into probability of D plus probability of T given D complement complement into probability of D complement. So first this term probability of T given D. So this can be computed from this value. Probability of complement of T given D is given. So probability of T given D would be 1 minus that. So this term would simply be 1 minus 5 by 100. So 95 by 100. And then this term probability of D is just 2%. It is already given in the question. So 2 by 100. And now this term probability of T given D complement. So this is already given here, this 1 by 100, and then probability of D complement, which is 1 minus probability of D. So it would be 1 minus 2 by 100, which is 98 by 100. So we have found out all the individual probability values. Now we can simply plug these values into this expression and find out the final probability value, which is probability of D given T. So if you compute the answer, it would be 0.66. So is there any question or doubt in this problem or in the solution? Yeah, so this question might be a little difficult, but basically you have to find out what these false positive and false negative values are in terms of the two random variables we are using, T and D. So once you find out what these terms mean, and then it's simple Bayes theorem again. Now question 5, it is given the probability of A given B is 2 by 3 and probability of A given complement of B is 1 by 4. So compute the value of probability of B given A. 4 options. First option is 1 by 2, second option is 2 by 3, third option is 3 by 4, and last option is not enough information given in the question. Pratik Tiwari has written option D. PB is not, yeah, so correct answer is option D. Not enough information. So even if you use these two probability values that are given, you will not get the probability of B, which is very much needed for this question, which is not given, and probability of B is not given, and you also cannot find out probability of B from the two given probability values. So that's why not information given. So option D is the correct answer. Yeah, Sankar Lal is also saying option D. Yeah, so D is the correct answer.
Just one question in that.
Yes.
Can we say that P, we can calculate PA just by summing 2 by 3 plus 1 by 1?
2 by 3 plus 1 by, no, that would not be probability of A.
A alone.
No, probability of A would be probability of A given B into probability of B plus probability of A given B complement into probability of B complement. So this is the theory of total probability. So this probability B and probability B complement, these two are also not known. So question 6, this is on Bayesian network. A patient goes to the doctor with symptoms S1, S2, S3, and doctor suspects diseases D1 and D2 and constructs a Bayesian network for the relation among the disease and the symptoms. So this is the Bayesian network given. D1, D2 are the two diseases, and these are S1, S2, S3. These are the three symptoms possible from the two diseases. So what is the joint probability distribution in terms of conditional probabilities? So joint probability distribution basically means joint probability distribution of all the variables given in this question: D1, D2, S1, S2, S3. So this is the joint probability distribution of this whole Bayesian network. So you have to find out this probability distribution in terms of conditional probabilities that you can find out from this Bayesian network diagram. Yes, Sankar Lal says option D. Okay. Pratik Tiwari is saying option D. So to find out joint probability distribution of all the variables in this Bayesian network, first you have to find out the nodes that are not dependent on any other nodes. So this node D1 and D2, these two nodes are not dependent on any other nodes because there are no incoming edges. So Manimaran Arumugam also is saying option D. So these two nodes D1, D2 are not dependent on any other nodes. So for these two nodes, it would can simply write probability of D1 into probability of D2. These two nodes are independent of all other nodes, so you can individually write these probabilities. Then this S1, this S1 is only dependent on D1. So for S1 you have to write probability of S1 given D1. Now S2 is dependent on both D1 and D2, so it has two incoming edges, one from D1, one from D2. So S2 is dependent on two nodes, D1 and D2. So probability of S2 given D1 and D2 into for S3 is dependent on D2 only. There is only one incoming edge from D2 to S3. So for S3 you have to write probability of S3 given D2. So this is the overall joint probability distribution, and this is option D. So probability of D1 D2, these two nodes are independent. Then for S1 there is one incoming edge from D1 to S1, so you have to write probability of S1 given D1. Similarly there are two incoming edges to S2 from D1 and D2, so for S2 you have to write probability of S2 given D1 and D2. And finally for S3 there is only one edge from D2 to S3, so probability of S3 given D2. So you just have to find out for every node what are the nodes that it is dependent on, and based on that you can individually write those probability terms. So option D, and the detailed solution is also written here. Now question 7. In a Bayesian network, a node with only outgoing edges represent four options: a variable conditionally independent of the other variables, a variable dependent on its siblings, a variable whose dependency is uncertain, and option D is none of the above. Pratik Tiwari is saying option C. Anyone else? Shankar Lal is saying option A. The correct answer is option A. So that variable is conditionally independent of other variables. So that node has only outgoing edges. So that means other variables might be dependent on that node, but there is no incoming edge to that node. So if there is no incoming edge, that node is not dependent on any other node.
If no incoming node, it means it's a parent node, correct?
Yeah, it can be parent
I
node.
have
Yeah.
a question. Can it, as he asked, if it can be in the middle of somewhere, the node, then how we are certain?
No, it cannot be middle of somewhere, because this node only has this outgoing edges. So there is no incoming edge to that node. So it can only be parent to other nodes, but there is no incoming edge to that node. So it is not dependent on any other node. There can be other nodes like this, but there is no incoming edge to this node. So it cannot be dependent on other nodes.
Right. So whenever there is node, we will only assume it's the extremes.
Yeah. So these are like extreme ends of the Bayesian network. it doesn't have any incoming edge. In that case, it is not conditionally dependent on other variables. But other values like this node is certainly dependent on this, on its parent, because there is an edge, direct edge from it. But this parent node is not dependent on this child node or any other node.
And what if like the arrows are upwards? If you have drawn this downwards, what if they are upwards?
No, upwards, downward, the direction
I
doesn't.
understand that the direction is towards it. If you can just invert this drawing and change the arrows,
Uh,
then we will say the downwards. I mean the this side extremes, the lower side extremes are the nodes that are conditionally independent. Right.
Yeah, so basically you have to the direction basically implies the relation. So like the direction is towards this child node, so that means this child node is dependent on the parent, but if there is no other path from the child to parent, then the parent is not dependent on the child. There can be other paths also, like this, the network can be very large. So via some other nodes, there might be a path from the child to parent also. In that case, it might be dependent on the child. But if such no paths are found, no other paths are found, in that case the parent is not dependent on the child.
And if this, if we have an incoming to that node, the first node, then we will say it is uncertain, right?
Yeah, so if there are some incoming edges, like there is some incoming edge like this from some other node, in that case this parent has to be dependent on this node, obviously. Hmm. Now question 8, which among gradient boosting and ADA boost is less susceptible to outliers considering their respective loss functions? So option A is ADA boost, option B is gradient boost, and option C is on average both are equally susceptible. Aditya Chauhan has written option B, which is gradient boosting. Pratik Tiwari is also saying gradient boosting. So considering the respective loss functions, so if you look at the loss function of ADA boost, it is an exponential loss function. So we give the weight values to each of the misclassified points, and the points which are misclassified are given exponential weights. If you go through the expressions in the ADA boost, you can find out that ADA boost uses this exponential loss function, whereas gradient boosting uses the mean squared error or the squared error loss function. So the ADA boost, as ADA boost uses exponential loss function, so it gives too much importance or too much weight value to the outlier points, whereas as gradient boosting uses squared error, it doesn't give that much importance to the noise or outlier points. So that's why it might ignore those points, and it is better to ignore some of the outlier points, otherwise it would overfit too much. So from that point of view, gradient boosting is less susceptible to outliers, as it uses squared error, whereas ADA boost uses exponential error. Now question 9. How do you prevent overfitting in random forest models? There are four options: increasing the tree depth, increasing the number of variables sampled at each split, increasing the number of trees, and all of the above. I've got three answers in the chat. All three answers are option D. The correct answer is option C, increasing the number of trees. That is one way to prevent overfitting. So if you increase the number of so first option is increasing tree depth. If you increase the tree depth, then you make your model even more complex, and making your model much more even more complex means it is much more prone to overfitting. So option A is not right, and option B is increasing the number of variables sampled at each split. Again, that same problem. If you increase the number of variables or even the number of features in the data, it makes your model more complex, and it is much more prone to overfitting in that case. Option C is increasing the number of trees. So this is the advantage that you get from the ensemble algorithms or ensemble methods, that if you increase the number of classifiers or increase the number of trees in the random forest, it reduces the variance. And if the variance is reduced, overfitting, there is lesser chance of getting overfitting, because overfitting basically means low bias and high variance, and if you increase the number of trees, it reduces the variance, which is almost the opposite of overfitting. So it helps the model prevent overfitting.
If we have this B option as decreasing, then it will also prevent it.
Decreasing the number of variables, it might be right that if we decrease the number of variables sample at each split, in that case it might prevent overfitting. Even if you decrease the tree depth also, so the model becomes a little simpler, so it is less susceptible to overfitting in that case. Question 10. Ensembling in random forest classifier helps in achieving reduction of bias error, reduction of variance error, reduction of data dimension, and option D is none of the above. Pratik says option B, which is reduction of variance error. Anyone else? Shankar Lal is also saying option B. Yeah, so the correct answer is option B. So as I told in the previous question also, so if you increase the number of trees in the random forest, it reduces the variance of the output. So for any ensemble algorithm this is true, and also true for random forest, that it reduces the variance error. Question 11. So this is the last question of this session. Consider the following graphical model. Which of the following are false about that model? Multiple options may be correct here. So this Bayesian network is given in this figure. and you have to find out whether different pairs of nodes are independent of each other given a certain node. For example, option A is independent of B when C is known, and you have to find out the false options here, not the correct options. So you have to try out all four options, and you have to mark all the options that are false. Mani Maran is saying A, Pratik Tiwari is saying A and D, Shankar Lal is saying B and C. So you have to find out the false statements, not the correct statements. So you have to check each option one by one. So let's first check the option A. A is independent of B given C. So A and B given C. So there is so you have to find out all the undirected paths. Like this is one path, and if so if C is known, so in such structure where this A, B, so C, so C has two parents A and B. In that case, if C or any of the descendants of C is not known, then A and B are independent, and if C or any of its descendants are known, in that case A and B are if in that case these two are independent. So in this case C is known. If C is known, this path is not blocked. This path from A to B, this path is not blocked, and similarly any of this is another path from A to B, and so if even one path is not blocked, then these two are dependent on each other, not independent. So A and B, so this option is this statement is false. That means it is a correct answer of this question. Then option B is D is independent of A given C. D and A given C. So C is given, so C is blocking this path from A to D, this undirected path from A to D. So this path is blocked, and there are two other paths like this and this. So you have to check if all the paths are blocked or not. So first check this path via B and C. So this path is not blocked because this B is not given, not blocked, and this for this this segment ABC, this segment is also not blocked. So that means this path is not blocked. If even one path is not blocked, then these two are not independent. Oh sorry, 1 minute. C is known. Oh, let me check the answer. A and D. So this option it should be correct. B, D, C. So for this path, whether this path is blocked or not, DBC, this segment is not blocked, and for this segment is not blocked. So in that case, yeah, this path is not blocked, so these two paths are not blocked. Finally, this path, whether this path is blocked or not, DECA. So this segment is blocked because this E is the common child of these two, so this path is certainly blocked, and so that means there is one path which is not blocked, this path. If this path is not blocked, that means A and D are dependent on each other. I'm getting a little confused with this options. Let's check the other options first. This is D is not independent of A given when B is known. Okay, so let's check this one. D and A given B. If B is given, this path is blocked, but this path is not blocked, so that means A and D are not conditionally independent, and that is what is written, not conditionally independent. So this cannot be right because you have to find out the false options. And final one is D is not independent of A when C is known. D and A when C is known. If C is known, then this path is blocked, and if C is known, then this path is whether this path is blocked or not, this path would also be blocked because of C, and if this path would also be blocked, so that means D and A, all the paths from D and from D to A or A to D are blocked, so that means A and D are independent of each other, all the paths are blocked because of this C. So yeah, so that's why this would be wrong, they are conditionally independent, so that's why these two would be the correct answers. Yeah, I missed that one there. So these two are false, A and D, so that's why A and D are the correct answers here. Yeah, so this question might be a little difficult to understand, but you have to apply the D-separation rules. I hope all of you have gone through the video lectures where the D-separation, there are 3 D-separation rules given, which you have to apply on these graphs for every undirected path from one node to the other that are given. You have to find out that the path is blocked or not given the evidence using those 3 D-separation rules, and if all the paths are blocked, in that case they are conditionally independent, and even one path is not blocked, then those two are not independent. So this is how you have to calculate the answers. Oh, 1 minute, A and B, I got it wrong again, I think. So yeah, D and A, let's do this option B again. D and A and C is known, this path is blocked. For this path, this triplet D, B, C is not blocked, and ACB, this is also not blocked. So this path is not blocked. So we have found out one path which is not blocked. So if even one path is there which is not blocked, in that case those two nodes cannot be independent. Yeah, so this is not right. Then this would be right because these two are complements. Yeah, so in that case A and B are the two correct answers. So I got it wrong in the first time. So this undirected path from D to A is not blocked. Even this path is also not blocked. So if you find the undirected path from A to D which is not blocked, then the nodes cannot be independent of each other. Yeah, so A and B would be the correct answers. So, do you have any other doubt in this question? Yeah, it might be difficult to explain it in this tutorial session. This independence, conditional independence in Bayesian network. So it will be better if you go through the video lectures. The deseparation rules are given. You have to apply those 3 deseparation rules on the Bayesian network given for the 2 nodes and the evidence, and then it would be clear. You have to find out every undirected path between the 2 nodes, and now you have to check whether all the paths are blocked or not. If all the undirected paths between the 2 nodes are blocked, then those 2 nodes are conditionally independent, and if you find at least one path which is not blocked, then those 2 nodes are not conditionally independent. So these were the practice problems that I wanted to discuss in this live session. Now if you have any other questions or doubts regarding any of the problems solved in this live session, you can ask me. If there are no other questions or doubts, then we can end this live session here. Thank you everyone for joining. We will again have another live session next week. Thank you everyone.